18.8 billion kilometers. Do you know how many Michael Jordans at 1.98 meters could fit in this huge distance? The answer is approximately 9,500 billion. Yes, it would take 9.5 times 10 to the power of 12 Michael Jordans to reach Voyager 2. Yet we are still receiving a signal from it. We are receiving information about plasma, charged particles, and solar winds. Voyager is the first interstellar mission of humanity. We never went so far, but sometimes we lose touch. Follow me on this grand tour to get to know how we re-establish contact with the Voyager 2. You'll find cute pictures of Neptune, Saturn, Jupiter, and Uranus, and maybe Michael Jordan. Also, do you have any idea how do we communicate with Voyager 2? You'll find out in this video. Enjoy! In the summer of 1977, NASA launched two of the most iconic missions in the era of space exploration. We are talking about Voyager 1 and Voyager 2, that left for the tour that is known as the Gran Tour of the Outer Solar System. The trip was made possible thanks to a peculiar alignment of the planet that made possible to make gravitational leaps from a planet to another. This technique is known as gravity assist. They visited Jupiter, Saturn, and then Uranus and Neptune. But why did NASA launch two probes? It was because one of them had to visit Titan, the moon of Saturn. That was at the time one of the most intriguing places in our solar system because it was the only moon in the solar system with a big atmosphere. But Titan was pretty much away from Saturn, so if you wanted to visit it, you just had to go straight in its direction. And once you've done this, you unfortunately can't take back the gravitational assist from Saturn to reach Uranus and Neptune. So you can continue your trip, but you can't go in the direction of the other target planets. So the goal was we launch Voyager 1 in the direction of Titan, and if the mission works out well, we can continue our grand tour by means of Voyager 2, that isn't directed to Titan, but takes the gravitational assist to Saturn and goes towards Uranus and then Neptune. But if Voyager 1 failed, we can divert Voyager 2 and send it to Titan. This shows that Titan was an important target to reach in order to understand more of our solar system. And maybe it was considered more important to reach than Saturn, Uranus, and Neptune for the purpose of the mission. The only reason why we have been able to see Uranus and Neptune in that period was that Voyager 1 successfully completed its mission. So we have to thank the effort and the passion that was put in Voyager 1 if we have been able to visit Uranus and Neptune. In fact, if Voyager 2 was diverted, maybe today we would have missed the chance to visit two of the most important places of our solar system. Thanks, Voyager 1. So everything worked out well, and Voyager 2 visited Jupiter in 1979, Saturn in 1981, and then Uranus in 1986, and Neptune, the last one, in 1989. Voyager 1 and 2 took some pictures. We suggest you take a deep breath and see how beautiful they are. The Grand Tour came to an end, but the probes were still active, and so they continued to monitor and send pieces of information to Earth. Information about the outer solar system, solar winds, charged particles, stellar dust. In fact, at that point, there wasn't much to photograph. But why didn't Voyager visit Pluto? It was because Pluto wasn't aligned in the right way, so that they could not divert the probe in its direction. Actually, there was an idea to send another probe, the Voyager 3, to Neptune, but unfortunately, there were no more funds, so Voyager 3 and 4 had never been built. But the interesting fact was that Voyager 1 and 2 continued to send back data back to Earth, and nobody was expecting to see them survive much longer. Somebody was saying that maybe they could have resisted until 1995 or something like that, maybe even until the year 2000. But the only one that was imagining a longer life was Carl Sagan, that was the chief for Voyager Images Reconnaissance. But he is most known as the one who created a message that wasn't designed for humans, the Golden Record. That message is a collection of images, sounds, and mathematical symbols recorded on a gold-plated phonograph disc that's still flying around through space today. December 17, 2020. Since NASA knew the spacecraft would travel farther than any man-made object in history, the space agency decided each robot should carry a message in case an intelligent civilization bumped into one of them. Sagan led the committee tasked with putting that message together. However, the Voyager missions went further than Carl Sagan ever dreamed. Guess what? They are still active. And not only do they still say hello to us, but they're actually making true science, true scientific discoveries about an ambient that we never visited before them. These are the first interstellar missions of humanity. This is the first time that we do such an experiment, so every time we receive some new info about charged particles, plasma, electric fields from Voyager, we can test our models and verify whether they are correct or not. Anyway, after the probe was left flying solo for 7 months while repairs were made to the radio antenna in Australia used to control it, on October 29th, NASA re-established contact with its Voyager 2 spacecraft. Mission operators sent a series of test commands to Voyager 2 using the antenna, which established a signal confirming the call was received. The spacecraft executed the commands without issue, according to a NASA statement. Can you imagine how amazing it is? Voyager 2 has been traveling through space since its launch in 1977 and is now more than 11.6 billion, yes, billion miles, 18.8 billion kilometers from Earth. It's about the same distance that you would travel if you went around the world 469,120 times. Or maybe one can imagine that it is the distance traveled by the speed of light in a light interval of 21 hours, 1 minute and 44 seconds. But this is not the end, because Voyager 1 is now more than 22.695 billion kilometers from Earth. If this distance was covered by Michael Jordan's height, 1.98 meters, we would have that the Earth-Moon distance would be 0.033 millimeters. We are very small, but they are too far from us. How do we communicate with Voyager? Well, we send radio waves. Electromagnetic waves travel at the speed of light. So, as we said before, it takes 21 hours, 1 minute and 44 seconds for a signal to go from Earth to Voyager. Double this time and you'll get the time we need to have a conversation with Voyager 2. In order to communicate with Voyager, we make us a series of antennae around the world, Deep Space Network. The antenna diameter is about 70 meters. That is about, guess what, 36 Michael Jordans. One of these antennae is the so-called DSS-43 antenna. Deep Space Station 43, DSS-43, was constructed between 1969 to 1973 as a 64-meter diameter antenna. The 64-meter antenna was more than 6 times as sensitive as DSS-42, the original 26-meter at the complex. Therefore, DSS-43 could communicate with spacecraft at greater distances from Earth as the signal became weaker. DSS-43 supported, as needed, the Apollo 17 mission to the Moon before the antenna's official opening in 1973. DSS-43 was extended from a 64-meter diameter antenna to a 70-meter diameter in 1987 to enhance its capabilities for the Voyager 2 1989 encounter with Neptune. It is the largest steerable parabolic antenna in the Southern Hemisphere. Recently, we updated it again, and that's how we re-established contact with Voyager 2. What makes this task unique is that we're doing work at all levels of the antenna, from the pedestal at ground level all the way up to the feed cones at the center of the dish that extends above the rim, says NASA Deep Space Network Project Manager Brad Arnold. This test communication with Voyager 2 definitely tells us that things are on track with the work we're doing. We hope that we can continue to communicate with Voyager 2 at least until 2027. It will depend mostly on the amount of energy, plutonium. Plutonium will continue to decay until it won't be able to provide sufficient energy to the various instruments on board Voyager 2. Anyway, if we could reach the year 2027, it would be amazing because it would be the 50th anniversary of the launch. Meanwhile, Voyager missions are continuing to provide science for us. Before ending this video, we would like to show you how the Earth looked when Carl Sagan decided to take a picture from Voyager 1 when it was 6 billion kilometers away, far beyond the orbit of Neptune. The Earth, the blue dot about halfway across the brown band on the right, seen from 6 billion kilometers, appears as a small dot in the darkness of deep space. Voyager also took similar photographs of Venus, Jupiter, Saturn, Uranus, and Neptune. Assembled together, they formed the photo called Family Portrait. The planet Mercury was not photographed due to its proximity to the Sun, and Mars is not visible due to the effects of sunlight on the camera optics. In 2001, in an article on Space.com, Ray Villard of the Space Telescope Science Institute and Juri van der Wood of the Jet Propulsion Laboratory voted the photo as one of the 10 best scientific images of space of all time. We are living in a fantastic era, an era in which we can send a probe to the outer solar system and still communicate with it. An era in which we have a powerful instrument to use for our purpose. An era in which we can see the Earth getting smaller and smaller, becoming a pale blue dot and then fading away from our line of sight. The Voyager era.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.